So we've talked about binomial random variables, and we want to actually calculate probabilities involving binomial random variables. How do we do that? Well, we can do it by hand, but often that's not efficient. So I'm happy to show you how to do it by hand and to talk about why the numbers are what they are. But for right now, just to get started with the concepts of the problems, let's use a computer to calculate the probabilities. And if you're ever getting paid to do this, this is what you'll do, of course. You won't waste your employer's time by showing how smart you are doing math by hand. The important things to know in these types of problems are what you might need to calculate, and then how to get the calculations from the tool. And usually what you need to calculate is the challenging part. Once you figure out what you're trying to calculate, then you can do an internet search, figure out how to calculate it. I'm going to use a spreadsheet to do these calculations. You can use whatever tool you want as long as you can show work with it. So that might be that you take a screenshot. The nice thing about spreadsheets is you can just type in to the quiz or the test what you would type into the spreadsheet to tell me how you got the answer. If you choose to use a graphing calculator, don't. I don't like graphing calculators, and the graphing calculators are so complex. They're almost as complex as the spreadsheet programs. They're far less powerful, far less useful. Just throw away your graphing calculator and start using a spreadsheet or other kind of computer tool to start doing these calculations. For these calculations with binomial probability, I'm a big fan of the binom.dist function. If you're not using Excel, you can find something that's equivalent. 95% of the class said they were using Excel. Many people said they were comfortable using Excel. So I'm kind of leaning into that and saying that we're going to use Excel and we're going to use this function to calculate what we want. Binom.dist command takes 4 arguments, 4 things you need to plug in. Remember that with binomial probability, we're looking at a fixed number of trials and a fixed probability of success. First thing that it wants is the number of successes that you're looking for. The second thing it wants is the number of trials. This is what we called n previously. You'll usually see this variable denoted by n when you look at binomial probability problems. Then you're looking at the probability of success, which is p, and this is the important key concept that requires some thought, whether the calculation is cumulative. So now let's talk about what cumulative means. The other 3 things are usually straightforward. You can just get the numbers from the problem, but sometimes there is some thought involved in determining whether or not this calculation is cumulative. You're looking at cumulative probability. You're looking at the probability that a random variable is less than or equal to a given value. You'll know that you're calculating cumulative probability if what you're looking for involves a range of values that starts at 0 and goes up to a number. So let's see some examples of what this might look like. All we're going to try to do here is identify what we would plug into our binom.dist function, or what are the key pieces we need for this binomial distribution. Here's the question. Suppose a fair coin is flipped 5 times. What is the probability that there are exactly 2 heads? To make this be a binomial probability problem, we need to identify a success and the probability of success. So we are defining a head to be a success. And the probability of success then is 0.5. There's a 50-50 chance. Since it says 2 heads, we're looking at 2 successes. Because we're flipping the coin 5 times, that's 5 trials. We're trying to do this 5 times. We've already said the probability of success is 0.5. Now the question here, is this cumulative? And the answer is no. This is not an example of cumulative calculation because it says exactly 2 heads. We're not looking for 0 up to 2 heads. We're looking for exactly 2 heads. So this is not a cumulative calculation. And because of that, when we go to type this into our computer, we would put false for that final variable. You can see here how I'm mapping the numbers from the setup to the function. So 2 successes goes in the first slot. Then 5 trials goes in the next slot. Probability of success goes in the 3rd slot. And this should actually be 0.5. Not 0.5. And because this is not a cumulative calculation, we put false in the last slot. So now we're going to look at a second question, and it's the same setup. We're flipping a coin 5 times, but now there's a different question. What is the probability that there are at most 2 heads? So if I look at the possible values of heads that I could get, at most 2 heads says I could have 0, 1, or 2. Now all of the numbers are the same as before, but I'm changing the type of calculation I'm doing. Now this is a cumulative calculation. This is a cumulative calculation because we're starting at 0 and going up to 2. So when we go to do our binom.dist command, the numbers will be the same, but our final, because we're looking at a cumulative value here, here, 0, 1, or 2 heads. Now this is true. This is a cumulative calculation. So this looks like the previous example, except all the numbers are the same, but the final argument of whether or not it's cumulative is true. Now let's look at this just slightly more abstractly. Let's just say that x is some binomial random variable where n is equal to 10 and p is equal to 0.3. And I'm interested in the probability that x is less than or equal to 4. So I see the key numbers here. I need to know what this means. I need to know how to interpret. This means that I'm doing 10 trials or 10 attempts. N is the number of trials. Probability of success is 0.3. And I'm interested in the probability that there are less than or equal to 4 successes. So in terms of my setup that I'm looking for here, the number of successes that I want is 4. But let's be careful. This is cumulative, because if I thought about what values I would accept, if I get 0 successes, is that okay? Yeah, that's less than or equal to 4. What about if I get 1? Yeah, if I get 2, if I get 3, if I get 4. These numbers are the numbers that are less than or equal to 4. So because I'm dealing with a range here of values from 0 to 4, this is a cumulative calculation. The other numbers I need are what is the number of trials, which is 10, and what is the probability of success, which is 0.3. So I take those numbers and plug them into the binom dist formula, 4, 5, 0.3 true. Okay, so now let x be a binomial random variable with n equal 10 and p equals 0.3. And we're going to find the probability that x is equal to 4. So probability x is equal to 4, this is exactly one value. So because it's exactly one value that I'm looking for, the only thing I care about here is hitting 4. So this is not a cumulative calculation. I'm looking for exactly 4. The other numbers are the same as before. I'm looking for exactly 4 successes. I have 10 trials, and the probability of success is 0.3. So I would plug into Excel binom.dist 4, 5, 0.3 false, and the false here is because this is not a cumulative calculation. So there are some more techniques that we might need. All of them will be based off this binom.dist function, but before we do that, I want to give you an opportunity to practice a little bit so you can feel confident in moving on to the next problems that might be more complex.